Hello, welcome to everyone in this video. This is our lecture number 10 of electronic series. So, if you want to watch the previous lecture, you can go through the description box, link are given there. And in this channel, there are different part of the physics, theoretical and problem solution discussed in different playlist. You can go through the description box, link are given there. You can see this is a syllabus which already covered this part, that is circuit and network, that is the Thevenin theorem, Norton theorem, maximum power transfer theorem, reciprocal theorem, superposition theorem discussed in lecture 1. Then semiconductor diode and application, that is PN junction, its applications, and then the bipolar junction transistor, this also covered up, and then the field effect transistor. So this up to that one in the lecture 9 we already discussed. So if you want to watch this portion, you can go to the description box. Today we want to discuss this part, that is regulated power supply, that is load regulation, regulation, Zener diode as a voltage regulator, the problem with the Zener regulation, requirement of the feedback and the error amplifier, and the study of series regulated power supply using pass and error transistor assisted by the Zener diode as a reference voltage supply. So you can see this one by one. And this will be the upcoming session: amplifier, feedback amplifier, and then multivibrator and oscillator will be covered up in upcoming session. Okay. So what do you mean by regulated power supply? Actually, regulated power supply is an electronic device where this output voltage is unchanged or it's maintained to constant, such that the input voltage or the load resistance or the temperature will be changed. Actually, when this input voltage change, the output voltage also change. If the load resistance change, output also change. If the temperature of these surroundings will change, output voltage also change. Uh, but when we use this regulated power supply, this regulated part actually control this change. That is, when we change the input voltage, the output change will not significant. This will be changed, but this will be not significant. This is the effect, and this is the main use of the regulated power supply. That is, with the change of input voltage or the load resistance or the temperature, the output voltage or current does not change. That is the regulated power supply. This will be actually mainly two types. First one is the load regulation and second one is the line regulation. Load regulation is this: when this load of the circuit is varied, when this load of the circuit is varied but the output voltage does not change, then this is called load regulation. And this load regulation measured by this parameter, that is VNL, that is the voltage with no load. No load means this load is zero. When this is zero, suppose you have a plug a mobile charger. There the input voltage in but the output voltage does not connect to device, that is the call no load. So this is the voltage with no load. But when we connect the load, that is the mobile, then the voltage is known as the voltage with the load, and this will be the VL. So their change with this VL is known as the load regulation. This is the load regulation. Okay. In case of ideal load regulation, this difference must be zero. When this difference will be zero, then this is called ideal, because in regulation the output voltage must be constant. So with the change of load, if the output is constant, this the change is zero. So for ideal case, this load regulation must be zero. What about the line regulation? Line regulation is the output voltage is constant when the input voltage varies. With changing input voltage, the output voltage does not change. This is called line regulation. So the measurement will be like that. This is the variation of load voltage with the variation of input voltage. That means when the input voltage change from value, then what is the change in the output voltage? Their ratio represent the line regulation. In the percentage, they are multiply a 100. Okay. So this is the line regulation. So load regulation when the output resistance is changed, and line regulation when the input voltage is changed. Next one is the ripple rejection ratio. This is the part where we measure also the how the regulation is performed. This is rejection is the ratio of the two, that is the output voltage ripple factor. Ripple factor means the changed part of this voltage. This is the constant part and this will be the changed part. So this is called as the ripple part of the output voltage, and the ripple part of the input voltage is the ratio of these two parameters is known as the PSRR, that is the power supply rejection ratio or the ripple rejection ratio. So these are three parameters by which you can measure the regulated power supply, how this power supply is regulated. Regulated means the output voltage does not change with the effect of load or the input voltage or the temperature. Uh, Zener diode actually can be used as a regulator, means voltage regulator. How? You know these characteristics of a Zener diode, that is the forward bias and this is the reverse bias. And you know in the reverse bias, after the Zener voltage, this current change hugely and voltage does change significantly. These characteristics actually help us to understand the voltage regulation. You can see here in the reverse bias of this Zener diode, after this Zener voltage, that is the breakdown voltage of the Zener diode, their voltage change is negligible. That means voltage does not increase significantly. So the voltage is constant, and you know the regulation is nothing but the constant at a particular value. So here this voltage, that is the voltage across this Zener diode, is nearly constant. This is changed slightly but nearly this will be the constant value. This is known as the voltage regulation. You can see you can make the line regulation or the load regulation with this Zener diode circuit. You just connect this Zener diode with the series resistance, and this is the input voltage and this is the load resistance. Now load regulation is nothing but when the load resistance is variable. So the input voltage is constant and the load resistance is varies. For very small value of RL, the IL must be infinite, very large. So if this is very large, the IZ becomes 0. When IZ becomes 0, the voltage across the load will be nothing but this current flow path, this region. This is not acting here. The load will be load across the voltage will be resistance will be like that. And minimum load is required when you just require the minimum load for which this is acting. So this voltage across this one is the Vi minus Vz, sorry, voltage across this one is the Vi minus Vs, and divided by Rs, this is the current into the general voltage, because above the voltage of these two terminal is the general voltage. So finally you will get this value of Is, that is the current to this series resistance. And the minimum load current is nothing but VL by R min. So finally you will get this value. And voltage across the series resistance is nothing but, so from here you will get the value of RS, that is the value of series resistance. Okay. So when the load resistance is less than the minimum value of load resistance, the output voltage must be equal to the input voltage, and this when this is you have to understand here the difference of these two. This is nothing but the general voltage. Okay, so the output characteristics will be like that. And line regulation also find out using the Zener diode. Line regulation is the nothing but the when the input voltage is changed. When the input voltage is changed. Okay. So the circuit diagram will be like that. The VL is like that, and minimum input voltage will be like that. So maximum input voltage like that. So for that, when the V input is less than Vz, the output is V input, and when it's greater than, the output will be Vz. Okay. The value of Rs in the series resistance can be found out very easily using this Kirchhoff's law. This is the value. You know the general voltage and Pz is the general power. Then the general current can be found out by power by voltage. For RL tends to infinite, IL must be 0. So I so RS equals to voltage by current. The voltage along that one is the VZ, and the maximum voltage will be like that. So finally you will get this one. So from this expression you will be get the value of series resistance. This is an example, you can understand this problem. An unregulated DC power supply of 40 volt, this is the DC power supply with 40 volt is applied to the Zener regulation shunt, because this is parallel with this load. To give the regulated power supply of 10 volt, this is the regulated power supply 10 volt. The series resistance 3 kilo ohm. Calculate the current through the Zener diode and also current through the resistor. So current through this resistor is nothing but this voltage difference, that is 40 and this is 10. So this current will be 10 milliampere, resistance R, that is current through the road resistance is nothing but this voltage and resistance is like that. So this can also find out 5. So this is 10, this is 5, so current to the generator is 5. Simple. Now comes into this series regulated power supply. Actually in this diagram or the characteristics, this is the practical breakdown diagram. So this voltage is slight change, but we need to know about the fixed. So this can be obtained by using this series transistor. Okay, here this is a fixed voltage and this is a variable resistance which actually control the output is constant. You can see here this is minus plus and this is plus minus, so this final voltage will be minus Vz minus Vb, Vz minus Vb. And you can see this is forward bias and this is reverse bias, and this forward bias can help this resistance changes, variable resistance actually. Finally the output will be constant like that. Okay, so that's it for today. Actually we will discuss in the next part in upcoming video. This is all about me. This is my contact detail and this is my YouTube channel details. Go to this channel, you will get the related video like this one. If you learn something from share this video, so share friends. This channel, if you need this channel, those already subscribe, press the bell icon to get notification of upcoming videos. So take care. We'll meet in the next video. Thank you.